Alright, in this section we'll be going over proof for the quadratic formula. Normally I don't like showing you guys formulas without you guys understanding where it comes from. So the process for finding the quadratic formula is the same as completing the square. So we're going to be looking at two examples, one with just numbers and then one of a generalized example. And by seeing how we complete the square, you guys can see where the quadratic formula comes from. Let's go and watch this clip and see what our goal is. So when we do the quadratic formula, we're trying to get this equation here. Alright, so again, no copyright, but again, let's try to manipulate and move the equation around so we get something like this. Okay, remember that this is our goal. So moving forward, here, notice that we have 4x squared plus 24x plus 1. In order to complete the square, we don't want a coefficient in front of the x squared, so we're going to have to divide each term by 4. So we can cut it in half, and then divide it in half again. And notice that here we divided each part into 4, so now we only have x squared. Similarly, if we're just having letters a, b, and c, I want to divide by a so that I get rid of everything in front of x squared. So we're going to divide by a. See, everything is divided by a, and now we only have x squared. So that's our first step for completing the square. Next, we're going to move this constant to the other side. So let's move this to the other side. All right, 1/4 is now over here. And again, the constant here is the c part, so we're going to move that to the other side. So here we have it here. Next, in order to complete the square, if I have 6 x's to make a box, I need to put half over here. Okay. And I need half over here. Right, and same thing here. Even though I have bx over a, all the b terms, I'm going to split that in half. And I'm going to put half right here, and then half down here. Right. Now that I split it in half, I'm starting to get my box. Now to complete the square, I need to figure out how many units I need in the corner. So for a 3x3 square, I need 9 units. And again, we're going to add 9 to both sides, add 9 to both sides. And here, if this is b over 2a by b over 2a, we need a section that's b squared over 4a squared. Again, not too important where this comes from. Just think about we're completing the square. We're filling in the constant gap here. Okay. So from here, now we can factor this. This is x plus 3 times x plus 3, base times height. So we have x plus 3 squared. And here, base times height, x plus b over 2, x plus b over 2a, x plus b over 2a, and we get x over b over 2a squared. We have a perfect square. Now that we have it as a perfect square, we can square root both sides, square root both sides. When we square root, there's always going to be 2 answers. There's going to be a positive and a negative version. So notice that there's a plus minus here, a positive and a negative version. Right? And now we want to simplify. We're going to complete the square. So to get a common denominator, I need to multiply both sides by 4. So times 4 times 4, we get 36 over 4. Right, and here, to get a common denominator, again, the common denominator is going to be 4a squared. So I need to multiply by 4a. 4a times a is 4a squared on the bottom, which is our common denominator. And then 4a times c is going to be 4ac. All right, now that we have a common denominator, we can combine the terms. So 35 minus 1 would be 35 over 4. And over here, again, we're going to have the same common denominator. Oops, denominator. And b minus 4ac is going to be b squared minus 4ac. And starting to get closer to what we want, our quadratic formula. Okay. Now we're going to square root the denominator. Square root of the 4 is 2. Square root of 4a squared is 2a. Again, 2 times 2 is 4. A times a is a squared. All right. Now all that's left is to get x by itself. Again, to get rid of plus 3, we can minus 3. Move that to the other side. And to get rid of b over 2a, we can minus b over 2a. And move that to the other side. So now that we solved for x, so one left thing to do, notice that down here, these have a common denominator. So we're just going to simplify this. And now we get negative b plus or minus the square root, b squared minus 4ac over 2a. So notice that we just followed the process for completing the square, but all we did was leave the letters alone, and we just did the same thing for completing the square. And after a whole bunch of algebra and moving things around, we end up with our quadratic formula. So knowing where it comes from isn't super important. What's more important is that we're able to use it. So let's go ahead and practice that. Again, here we have a equals 3. In front of x we have 7. Our constant is 2. Oops, constant is 2. And now we can plug that into our formula. All right, replace b with 7. Replace a with 3. And replace c with 2. All right, and there we go. That's one of our answers. And remember that when we square root, there are two versions, a positive and a negative version. And that's our other answer. All right, next one. A is 2. B is negative 9. And C, our constant, is negative 35. So let's go ahead and plug that into our formula. All right, every time I see A, I'm going to replace A with 2. Every time I see B, we're going to replace B with negative 9. And every time I see C, I'm going to replace C with negative 35. And after solving, like squaring, subtracting, square rooting, we end up with 7. And we have our negative version as well, negative. Right, so those are our two answers. And the last one, here A is 8, B is 10, C is 3. I'm going to plug those numbers into our quadratic formula. Every time I see A, replace that with 8. So A is 8. Every time I see B, replace that with 10. And every time I see C, replace A with C, or sorry, C with 3. All right, so that's one of our answers. And then again, square root minus, there's our other answer. And those are our two answers. So again, the quadratic formula, it's a way for solving for x. Right? By substituting the coefficients into the formula. And where does it come from? It comes from completing the square while leaving the coefficients as A, B, and C. All right, so now that is one more extra tool we can use to help us solve for x when we're looking at quadratic formulas. All right, hope you guys found that useful. And if you still have questions, let me know.